Go. All right, good stuff. Hi, everybody. How are you? Just terrible. What is the deal? Hi, hello, how are you? There we go, a little bit better. Okay, we don't have a lot of time, friends. We don't have a lot of time. I was hoping for 3 hours. They gave me 15 minutes. That's not nearly enough. So we're going to get well underway real quick. First things first. That is the slides. Those are the slides. Let me make that bigger. There you are. Those are the slides. It contains the most important information that you're going to need to be able to follow along at your own leisure later on at your own discretion. So take note of, if you take a note of one thing, this is it. This is the slide you should note. Take a photo of it, capture the 3 most important coordinates there. The first and topmost of which is the URL where you can find the code, which you can then peruse at your own time if you have time, if you're so willing. The second of which is my Twitter handle, so should you have questions, ineluctably, when you have questions, don't hesitate to reach out to me. Find me on the internet, so I'm happy to answer questions. Just quick show of hands, 2019, how many of you are using Twitter? How many of you are using Twitter? I'm always curious, Twitter, 2019. Okay, the rest of you, what are you doing? What are you doing? It's a great place to be. It's the new IRC. It's where the developers that drive the open source that power your business are, and you owe it yourself to be there. What about email? What about email? How many of you are using email? Anybody using email? Email, 2019. No, I'm not a big fan of email either, but it's an option, so you can find me there. I've had to soften my position on email in light of Slack. I have a brand new MacBook Pro 2019 with 16 inches of screen space and 64 gigs of RAM. And this, my friends, is finally enough to be able to run both Slack and Chrome. I'm finally at a place where I can do that. It took a long time. They announced the Mac Pro a few months ago. Did you hear that? At 1.5 terabytes of RAM, terabytes with a T. It lists under the specifications. You can run both Slack and Chrome. I thought that was a big deal. So find me there, find me on the internet. My name is Josh Long. I work on the Spring team. Before we get underway, is it okay if we take a selfie? Can we take a photo? Is that okay? Who ardently objects? If you have any aversion, let me know now, but I'd love to take a selfie. And there's a very important reason. You see, I have a daughter. My daughter's 14. She's very smart, very precocious. And I like to take photos of these crowds, and then I go home and I take the photo and I say, see, they listen to me. So when I say open source, everybody pretend like you're happy, okay? And we're gonna take a photo together. 1, 2, 3, open source. Ah, good stuff. Hey, bad monitor, bad. What just happened there? There we are. Good stuff. So moving on. My name is Josh. I work on the Spring team. I've been there for the better part of 10 years now, going on 10 years, almost 10 years, 9.5. I work on open source. I've got videos. I've got a book called Cloud Native Java, all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. The book is available in a number of different languages, including American, including Chinese, Korean, and Russian. There is no Australian version with all those extra goofy vowels, but maybe one day. I have a podcast you can find on all the podcatchers. There's that. I have a blog I do every Tuesday called This Week in Spring, and I have a vlog, a video log I do every Wednesday on YouTube, so you can find all that stuff. And today we're going to talk about reactive programming. We're going to talk about the subject of the book on which I'm working right now. This is my 6th book, and every time I've written a book, I've always said, I'm never going to do that again, and yet here we are. This book is all about how to take advantage of reactive programming. And reactive programming is not a particularly new thing. It's not a new problem, and it's not a new solution. The question that we're trying to solve here when we work with reactive programming is, hey, how can I handle more users? What can I do to support more users in my system? And there's a lot of reasons for which we might need this particular solution answered now that we maybe didn't need yesterday or yesteryear. Right? A lot of our applications just simply didn't have these scale problems until more recently. And so these problems are more manifest in the era of the sort of return to client service architectures. And this is something I've seen kind of get exacerbated in light of the iPhone and Android, right? As soon as we moved back to the world of client services where user interfaces actually result in a cascade of calls back to a back-end service, as soon as we did that, some very interesting things happened. It was no longer true that one HTTP GET request resulted in everything you needed to be able to render the response. Instead, one view resulted in a cascade of HTTP GETs. of HTTP calls that in turn have to call other things. This is sort of coincidentally arised along with the rise of microservices. So now we have this conduction of data from one point to another on the network. We have movement of data from one place to another in the network, and that has created more demand, more HTTP requests, more calls. And this isn't a problem in of itself. Scale is not a problem. Anybody who says otherwise is a liar. No, scale's a good problem to have. What it is, however, is it challenges the way that we've traditionally built software on the JVM. Think about how a web server written in yesteryear would have worked. You would have had a web server parked on port 8080. There's a java.net.server socket parked on port 8080, and as incoming requests come in, that server socket is accepting incoming requests, and there's a while loop, and it says, hey, while server socket.accept equals true, wait. And then as soon as a request comes in, you get an input stream from the incoming socket, and you put out an output stream, and you can conduct information back and forth, and that's how you produce a response. Usually we don't deal with code at quite that low a level. Usually there's probably something like a servlet API in between, but ultimately that's what used to happen. And that wasn't so bad, right? The only problem with this approach was that it eventually becomes a bottleneck. It eventually saturates, and it's not the actual input and output that's the problem, not on the JVM. On the JVM, the problem is that we run out of threads. Right? Because this approach requires you to sit there, and as you're doing work with these input streams, and as you're doing work with these output streams, you're waiting. You're just waiting. You're waiting for bytes to arrive. You're waiting for bytes to go out. And this is a problem, because when you're waiting, what are you doing? Where are you doing the waiting? In the JVM, you're doing that waiting on a thread. And that thread is the problem. That's where we get into some trouble. And then even if we had the ability to create infinite numbers of threads, which we don't, but even if we did have that, we get into another problem, which is that API, the way we think about data, this idea that we can just ask for the next byte to come around the network, that idea isn't very, very useful when you think about distributed systems where failures are almost a certainty, where things are going to disappear from out from underneath you, right? These are a different way of thinking about the world. So we have two kind of big problems here. One is we can't afford to have a programming model that requires us to waste threads, because threads on the JVM are precious. They're very, very expensive. And we also can't afford to have an API that just assumes the happy path and makes no provision for the all too real, all too probable failure mode, the degradation mode. So this is where reactive programming comes in. It gives us a way to do more efficient multi-threading. It gives us a way to say, hey, I'm asking for data to come in. That data is not here yet. When it gets here, give me a callback. Very simple idea. I'm describing data as a stream of things that aren't here yet. Is it here yet? No, but I'm not wasting time waiting for that data either. I'm asking the operating system, the kernel, to give me a callback when that data is available. Now this is a very, very useful thing, because it gives us the ability to do other work in the meantime, okay? Now, when we think about reactive programming, what we need is a data type that allows us to model data in this way, right? Let me see here. Something's going on. Go gadget screen. Come on. Good stuff, okay? So what we want is a way a thing that allows us to model data in this way, that allows us to say, hey, this data's not here right now, but I want to be able to hold on to something that'll give me the data eventually. We could use something like a completable future in the JDK, but this only deals with the question of, hey, I've got one thing that is going to be asynchronously resolved. It doesn't allow us to say I've got 2 or 10 or a billion or a trillion or infinite things. So we need something a little different. A number of different companies got together several years ago. Pivotal, Lightband, the Eclipse Foundation, Netflix, of course. All these different organizations got together, and we extracted out some common ground interfaces based on our understanding of this space. And this common ground set of interfaces is called the Reactive Stream specification. It's 4 very simple, very Spartan interfaces that we can use to build or to describe asynchronous streams of data, right? Potentially unbounded streams of data. And it has a number of other characteristics, which we'll look at in just a second. These are very, very boring types, however. I like to think of them as sort of discontiguous Java arrays. They don't really provide any of the support that you're going to need to do more higher level processing, things like mapping and flat mapping and filtering and operating on streams of data. For that, we have Project Reactor, we have Netflix's RxJava, we have Lightband's Akka Streams. We have a number of different projects that sit on top or implement or otherwise interoperate with the Reactive Stream specification. These things give us these operators. They allow us to describe pipelines. Is that enough? Are we done yet? Can we go to production with just that? Of course not, right? As good as these types are, as good as Reactor is, as good as all these things are, they're no good if they don't allow us to actually deliver software into production. For that, we need to be able to solve the daily sort of bread and butter use cases with which we're all no doubt familiar. Things like building web apps, things like doing data access and security. These are the things that allow us to ship value to our customers, and that, at the end of the day, is all that matters. So suppose that these technologies with which you're no doubt familiar, things like Spring, things like Hibernate, suppose that these things, for whatever reason, had no idea about Java util collection types. They really, really hated them, right? Imagine that for whatever reason, whenever you tried to map a Hibernate entity, do a one-to-many relationship with a Java util set, that for whatever reason, again, hypothetically here, friends, hypothetically, imagine that whenever you tried to map a one-to-many relationship with Hibernate, and you used a Java util set, that Hibernate didn't just throw an exception. Imagine that it also rendered an ASCII art middle finger. And then kernel panicked the machine. Would you continue to use Hibernate and Java util sets if you knew that you could continue to expect this kind of abuse? Of course not. I'm not suggesting you're going to give up on Hibernate. If the name of the game is to try and map JDBC data structures to Java objects, then that's the best thing there is, in a synchronous way anyway, right? If that's what you're trying to do, then that's the best thing you can do. You're not going to give up on your thing that gets you to production just because you want to use this clean Java util set type. You're just going to use whatever crazy thing they make you use, the path of least resistance, the path that gets you to production. So that's the quandary we find ourselves with respect to these reactive streams types. However good they are, however obviously useful they are, if they're not well integrated into our technology stack, then they don't serve our use cases. They don't serve our goals, and that's a problem more than a benefit. So the Spring team has integrated these reactive types. In Spring Framework 5 in 2017, in September, we released a first release of Spring Framework 5 that had a reactive web runtime integrated into the stack, on top of which we have since released Spring Data K, Spring Security 5, Spring Boot 2.0, and Spring Cloud Finchley, and a number of other different technologies that integrate these reactive types. And that, my friends, is the real journey. And that's the one that we're going to walk together today. And we're going to do that, of course. We're going to do that, of course, by doing my absolute favorite thing. We're going to go to my second favorite place on the internet, after production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion, after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application here at start.spring.io. There's a few things that are worth noting. First and foremost, we have dark mode. That's awesome. We're going to build a new application. I'm going to take advantage of the defaults mostly. I have to specify the name of the artifact. I'm going to call it the reservation-service. This is the thing I'm going to build here with you today. I have some options that I want to confront. First and foremost, the choice of packaging. People are often confused by this, so let me do my level-headed best here and now to explain when and where to choose which. If, by some fluke of physics, some terrible tragedy of time and space, you should find you have been somehow transported to the distant past. Far, far, far beyond modern help, then choose .war. But if you're here with me in 2019, nay, almost 2020, then choose .jar. This is a big part of my overarching and guiding personal philosophy of make jar, not war. And again, lots of things you could do, lots of things that you should do, but I'm going to encourage you to accept the default here. That's a good choice. Then, my friends, we have the choice of the JVM. What version of Java do you want to run in your code today? And my friends, before you have 3 different options, of which only 2 are acceptable. One is not acceptable. I'm not going to tell you which one it is. I'm going to give you a clue. When you figure it out, I don't want you to ruin it for the rest of the gang, okay? So when you figure it out, just be quiet, okay? I'm going to give you a little clue about which one's wrong, okay? Okay, don't tell anybody though. Don't tell anybody. So we have 2 other options that we can consider. The first of which is Java 11. Java 11 is the current long-term supported version of Java. This is an acceptable solution if you're a coward. If you want to, if you want to stay on the oldest version that you can still consider production supported, then that's fine, right? But if you're on a cloud platform that just sort of conveyor belts you to the next version automatically anyway, then you should really do the right thing and use Java 13. That's what I'm going to do because hashtag YOLO. Now, my friends, Java 11 and Java 13 are both infinitely better in every way. They're superior, they're faster, they're more technically secure, they're more robust, they're better supported. They have new language features. They're just better choices all around. They're technically the right choice. But friends, also consider that they're also morally the right choice. Morally. Are you prepared to have that discussion with your children? Are you prepared to have that discussion about running Java 8 in production in 2019? I think not, friends. I think not. So, we're going to leave those things as they are, and then we're going to bring in some of the dependencies that we need to be able to build our application. We're going to bring in Spring's reactive web support. We're going to bring in Lombok, and we're going to bring in reactive R2DBC. This is a reactive SQL data access API, and we're going to bring in RSocket. Okay, now these are just my initial selections. We could have selected a number of other things. We could have brought in, for example, reactive MongoDB, for example, or Couchbase, or Redis, or all sorts of different options. But I'm fairly content with the selections I've made, so I'm going to hit generate, and that's going to generate a zip file, which I am going to open up in my IDE. And it doesn't all that much matter what IDE you use. Anything will work so long as it supports, in this case, Java 13 and Maven. All right, so I've got this version of my application. Unzip and open. Take some decaf. Java. Now, anything works just fine. Anything will work just fine. I don't really have an opinion here. Anything's fine. You can use IntelliJ, you can use Eclipse, you can use NetBeans, you can use anything you like, but I have my new application. We're going to go ahead and bring that up. I'm going to make the font a little larger for those of you in the back, and that means you, camera. Here we are, 22, good stuff. Can you all see that in the back? Who can't see that? Who can not see that, okay? We're okay? Good stuff. So we're going to build a new application, and we're going to build an application that saves data to the database. So we're going to persist objects of type reservation to my local SQL data store. And I've got Postgres running in the background here. I've got Postgres back here. You can see orders, right? There's my database, okay? And I can say, show me the schema I have, and I can say, show me the information for the reservation table, and I can delete the data from the reservation thing. There we go. And now I have no data in there. What I want to do is I want to map my object to this table. It's a monotonically incrementing primary key of type integer. So I'll say private integer ID, and I'll say I want to have a private string name, okay, like that. And that's the essence of what I want to express. But this, my friends, is Java. So you need constructors, you need toString, you need equals and hash code, you need blah, blah, blah. So terrible, right? So just look at that. So Java, so 2019. Look at all that. So instead of doing that, I prefer Lombok. Lombok's a compile time annotation processor. It allows you to synthesize through these annotations at compile time the things that we just specified in code, that I code generated my way through. And I also want to specify that we have a primary key, so I'm going to annotate that particular field with the ID annotation. And there, my friends, is everything we need to be able to map that object to the table. Now I need some way of persisting it, something to manage the tedious, soul-annihilatingly, oh dear, come on, soul-annihilating, boring read, write, and update and delete lifecycle, the data management lifecycle. So I'm going to create a reservation repository, which is going to extend the reactive CRUD repository, which is a thing that's going to manage entities of type reservation whose primary key is of type integer. Now, keep in mind, this is just an interface. I don't actually have to provide the implementation of that. Spring will do that for me. This interface provides a number of different methods, some of which should be very straightforward. I suspect you can suss out based on the names what these things all do. You've got save, find, count, delete, check if it exists, etc. All of that is fairly straightforward. What may not be so straightforward are the input parameters and the return values, the first of which is a publisher. A publisher comes from the aforementioned reactive stream specification. It's a thing that publishes data asynchronously out of band to something else that consumes it, namely a subscriber. When the subscriber first subscribes, it is given a subscription. We're going to double click on that in just a second, but let's just leave that for a moment, okay? When the data eventually arrives, 1 record, 2 records, no records, 1 trillion records, infinite records, whatever, each time a new record arrives, the onNext method gets called and you get a callback. When there are errors, if there are errors, the onError method is called. And finally, when the publisher has produced all the data it's going to produce, the onComplete method gets called. This is the life cycle, right? The interaction between the producer and the consumer. Now, I mentioned the subscription, and the reason I want to sort of return to that, to return to this idea of a subscription, is because I think it's arguably the most important part of the Reactive Stream specification. It is a link between the producer and the consumer, between the publisher and the subscriber. It is a thing that the subscriber uses to request of the publisher more data. This is very important. The subscriber, the client, the consumer, the thing that is consuming the data is using this subscription to ask for more data, to control the rate of consumption, or to control the flow of data. This is control flow. It's not a new idea. Ever since we had one computer talking to another on the same network, we've had to think about control flow, right? This is not a new idea in any way, or flow control rather, right? Not a new idea in any way. In the world of reactive programming, where we sometimes confuse marketing with technical ideas, we've got this new term called backpressure. Basic, same idea. We, as a consumer, control the rate at which we consume data. You can't denial of service a consumer that is itself controlling the rate at which it consumes the data, okay? So this creates more robust services. It gives us the ability to say, hey, I'm not ready, so I'm not going to consume. I'm not going to pull down any more than I can handle. Now, I mentioned that there are 4 types in the Reactive Stream specification. We've mentioned 3, but there's a 4th one called a processor. Now, a processor is just a bridge, a source and a sink, a publisher and a subscriber. And that's it, my friends. That's it. That's the entire Reactive Stream specification. If you understand those 4 measly little types, you're ready. You're ready. You're already leagues ahead of people in Silicon Valley. Go to Silicon Valley, raise millions of dollars, create a stupid company, and come back a failure in 6 months. You're ready. You're way ahead of people in the Valley. Now, these basic types are foundational. They're discontiguous sort of Java arrays, but they don't give us, as I say, operators. So let's talk about 2 specialized types from the repository that we kind of skipped over before. The first of which is a Flux. Now, you may not give a Flux, but I like this type. A Flux is a publisher that produces 0 to n records. 0 to n being unbounded, okay? It has operators, lots and lots and lots and lots and lots and lots of operators, right? These operators support all sorts of different kinds of compositions and iterations and all that kind of stuff, right? That's cool. That's very convenient. We also have a mono. A mono is also a publisher, but it only produces at most 1 value. So it's 0 or 1, like a completable future, but with backpressure. And there you go. If you've got these 2 types, you've got more semantics. You've got the ability to say, hey, this is a thing that's going to be 1 record. If somebody asks you to render a publisher of type T, be it a customer or a reservation or whatever, you can say, hey, is this an overview page, in which case it would be a Flux of T, or is it maybe the details page for a particular record, in which case it might be a mono of T. They're both publishers. They both have the same semantics, but now you know it's probably only going to be 1 or many, okay? Now that we've got that out of the way, let's write some data to the database. So I'm going to create a Spring Bean, a class that's going to be an initializer, okay? So we're going to say initializer, not a liar. And it's going to be a Spring Bean, so it's going to listen for an application-ready event. And when the application, wow, I'm so low here. I got to get up higher. When the application starts up, we're going to get a callback here, and we're going to use that callback to write data to the database. So I'm going to say private final reservation repository. I'm going to inject that into the constructor, and I could do this the old-fashioned way. I could just say, code generate the constructor. But again, I'm a fan of Lombok at this point, so give me that, and there we are. Okay. Now, what I want to do is I want to just write the data to the database. So I'm going to create a little publisher of names. I'm going to just go through and get some names on the Spring team. My name is Josh. It is so nice to meet you all. Who else is on the Spring team? We've got Olga. She's amazing. We've got Madura. She's amazing. We've got Violetta. She's amazing. We've got Ria. She's amazing. We've got Dr. Sire. He's pretty cool too. We've got Spencer. And is that 8 yet? Did we do 8? I think that's 1, 2, 3. 4, we need 1 more. And we've got Stefan, okay? 2, there we are, okay? Missing that, okay? Now, we have a publisher of names. These are just names in a stream, and what I want to do is I want to visit each one and turn it into a new reservation like so. So there we are. There's the name of, there's our stream of reservations, and now I want to save each one of these to the database. I could do map like that. I could say, hey, for each one, I want to save by passing that in. I could just use a method reference, but look what I get when I do that. I get a publisher of reservations, and I don't want to do that. I want to actually have just 1 level of publishers because it gets confusing and it gets hard to manage. I want to flatten out that nested publisher. So use flat map, and flat map unpacks that intermediate type and allows you just to say, that, right? So there's my saved data. There's the saved publisher, the saved pipeline. Now, if I ran this code as is right now, nothing would happen. You see, this is called a cold stream. We've defined the pipes through which data will flow, but we've not turned on the proverbial faucet. There's no water flowing through these pipes. In order for that to happen, we need to say save.subscribe. And you can override or use one of the overridden methods. There's a lot of different options there. I can use a consumer here, and I can just log out their data. But of course, this is Java, so you can turn that long, verbose, anonymous inner class into a lambda, and that could be a method reference. And so there we are. Not bad, huh? Now, we're going to run this. But if I ran this program right now, what do you suppose would happen? Well, first of all, on the first run, we get 8 records. On the second one, we get 16, and the third one, 24, and so on. Eventually, we just get duplicative data. I don't want duplicative data. So I suppose what I really want to do is I want to, first of all, clean this up into a more modern pipeline. I'm going to remove all this sort of intermediate variables. That's fine, much better, okay? I can use auto inference there, good. And what I want to do now is I want to say, hey, let's delete everything first, delete all, and then I'm going to write the data to the database, and then, and only then, remember, these are asynchronous, right? So there's no guarantee that the delete all will happen before names. The only way you can guarantee that is by using these operators, right? So I'm saying do everything asynchronously first, and then do this, and then do that, right? And then finally, as the data comes back, I'm going to log it out. I'm going to stream out the results and print out the results from this find all operation. So let's see if that works. Let's see if that goes the way I'd expected it to go. Now, keep in mind, this is nice because this is all asynchronous. There's a lot of different things happening in here, right? I have an error. It says, hey, I need a database URL. So I'm going to use R2DBC URL. I'm going to give it an R2DBC database connection string. So R2DBC Postgres localhost orders, okay? I'm going to say username equals orders. And I'm going to say password equals orders. And voila, okay, there's my connection string. Don't tell anybody about my password. That's awkward. I did not expect this to happen. Some things should not be open sourced. Let's see. Did that work? Unable to create a connection factory. Oh, pool. Driver PostgreSQL. R2BC PostgreSQL maybe? Let's see. I just work here. Did that? URL, R2DBC, connection factory, driver, Postgres. Wait a minute. Do we have the Postgres driver here? No. OK, so the way you fix that is you go back to here, you specify, hey, Postgres. Choose that, and you can explore, OK? And you can actually just cheat. You can get the build that you would have gotten if you had just generated it correctly from the first time. Copy and paste that back into your build, and ta-da, all is forgiven, OK? There we go. So there's my R2DBC Postgres driver implementation. Add that to the class path. I'm pretty sure that I had the actual string right the first time around, so it's probably going to, oh, that actually did work, so let's leave it. Let's see if it works. Good, good, good. Rerun, good. Did it work? There we are. Look at that, my friends. There we are. There are the 8 records on the console. It's reflected in the output. You can see the names have gone to the database. They've round-tripped. They've been given a primary key, and you can see them reflected in the console here. It worked. Of course, it worked. It was a demo. It was a demo. That was always going to work. Of this, there is no doubt. That's not what I wanted to talk to you about. That's not why I'm here. What I flew across the planet to talk to you about is this. This is the Spring Boot ASCII artwork. Now, this artwork took a long time to get right. But we on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics, star stuff, the very celestial bodies in the heavens above us for their daily bread and butter. And so it's for this reason that I want to take just an ever so brief moment to talk about what I consider to be a glaring and serious deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. Do you see this checkbox right here? Right there. Do you see that checkbox? That right there. That checkbox right there. This one. Do you see this checkbox? That one right there. Do you see this checkbox? This checkbox, if you click it, do not click it. This checkbox, once clicked, suppresses the output of the ASCII artwork. What the hell? Why is that there? That's a dumb feature. Nobody even asked for that, IntelliJ. Seriously, why is that there? Worst idea ever. So I did what anybody would do in that situation. I went on the internet and I cried. And I was given a message of hope from my friend, Jan Sebron. This is Jan Sebron right here. I'm going to show you. He's a developer advocate at JetBrains. This is Jan right here. That's him right here. Okay? That's Jan, right? right there. Okay, right. Boop. Anyway, he sent me this message of hope, which I want to share with you today. I've known Jan a long time. I want to believe him when he says it's going to be fixed post-haste, and I want to believe him. I want to believe him every time there's a new release. I say, hey, is it done yet? Is it done yet? Please, tell me it's going to be in the next release. And he says, relax, Josh. Just chill out, Josh. Just relax. It'll be surely fixed in the next release. Just relax. And you know, I've known him for a long time, and I really want to believe him, but I'm starting to think that just maybe, he's not exactly on the level. Whatever. Anyhoozle. We've got now data in the database. We've got amazing ASCII artwork. The question people often ask at this point is, hey, can I build an HTTP API? And naturally, you could. There's a lot of different ways to do that. But let's just build a simple router function. Okay? So server response. And it's just a functional reactive endpoint that's going to provide a response when a request predicate is matched. So here we are. And we're going to say build. And it's going to be .get/reservations. Okay? Reservations. And new handler function, and it's just going to be the response. So server.body.response, and my job is to produce a response. In order to do that, I am going to inject a collaborating object, a reference to type reservation repository. I'm going to say, hey, when somebody makes an HTTP GET request to /reservations, this callback, this anonymous inner class, which is now a lambda, which is now made shorter by static imports, that lambda is going to be invoked to produce the response. Okay, so I can go ahead and restart this, and let's see what we get. Okay, it takes longer to compile Java these days than it takes to do anything else. So localhost 8080/reservations, and voila. Okay, there we are. There's our data, well reflected in the output of the HTTP endpoint. That's good, right? It's fine. Now I can hear a collective, like who cares? I just showed you how to do SQL data access and 8 records of JSON. You didn't need reactive for that. What's the point of that? That's all I've shown you is that you can do what you could have done yesterday with reactive today, okay? That's nothing interesting. There's nothing novel about that. So let's talk about use cases where reactive actually offers a net win as opposed to just being parity or just achieving parity. So reactive programming is really useful where you might have otherwise monopolized a thread, okay? In all those use cases where you might have written code that otherwise monopolized a thread. And it's not hard to imagine scenarios where this might have been the case in yesteryear, okay? Suppose you wanted to do something that required the client or the service to create an ongoing socket connection. And this socket connection is what the client uses to get fast updates. You want liveliness. You want to be sure that you're getting the latest information as fast as possible. So what use cases sort of scream out for this kind of approach in yesteryear? Well, things that require really, really quick live updates. Stock tickers and chat notifications and presence and all these kinds of things. That approach is problematic because it requires that you create a thread. In the old approach, you'd keep that socket and you'd keep that thread. That's where we get into trouble. So what I want to do is actually, I'm going to create an endpoint here. And I'm going to create an endpoint as a set of WebSockets. We're just going to create a WebSocket endpoint. And I'm going to create an infinite stream of values. So let's go ahead and do that. I'm going to go ahead and create a simple service here that will just greet people. Okay, just a greeting service. Here we are, a greeting service. And it's going to create an infinite stream of greetings responses given a greeting request. So here's that, and I'm going to say greetings request, et voila. Okay. Now here's my greetings response. The response will be a message, and the request will of course have a name. So these are kind of like DTOs, right? I'm going to create the DTO by using the Lombok annotations that we've already been introduced to. Here we go. Paste. Okay. Now, given a request, I'm going to return a stream of responses. So here we are. Greetings request. Good. Now, I'm going to say return flux.fromStream. I'm going to create an infinite Java stream of supplier with a new supplier. I'm going to create a new greetings response. Okay, so new greeting response. And I'm going to say hello, or I suppose a good day. There we are. Request.getName at, and we're just going to log the time because, we can. We've got the computers. So here we go. There's my infinite stream. That's going to produce new values in perpetuity, right? And that's going to be problematic because we can't really just it'll just scroll it off the side of the screen, basically. So I don't want to do that. So what I'm going to do is I'm going to stagger the output. I'm going to delay the output of the records just by 1 second so we can have a hope of following it along. And I can do that by using this operator on Flux called delay element. And the reason I have an operator that gives me the ability to control time is because Reactor ultimately has something called a scheduler. A scheduler is 1/2 thread pool and 1/2 clock. And that clock is what helps us do some of the most interesting work that needs to be done when you do reactive programming. Namely, it allows us to effortlessly move the execution of our program from one thread to another without us having to worry about how that gets done. You don't normally need to worry about that, right? So for example, if I were to go back to this original pipeline here, I created this pipeline that had these asynchronous details, these asynchronous things that were happening, and they're happening on the default scheduler. By default, the scheduler that you get in Reactor is a scheduler with 1 thread per core. Okay, so you get 1 thread per core, and so long as you don't block any of those threads, it works out just fine. But if you do block the threads, if you do something that blocks the thread, and what are some of the things that block a thread if we've moved away from I/O? What other things can still block threads? Well, what kind of work do you do on the CPU, right? What things can pin down our CPU? So Fibonacci, right? That's a thing that will end up blocking the thread. Cryptography, Bitcoin mining, Slack, right? These are things that eat lots and lots of CPU power. So what we want to do is we want to avoid that kind of work, right? So you can do that. If you have something that's going to do this blocking interaction in your code, you can cordon off that particular interaction by saying, hey, I want to subscribe on a particular scheduler. You can say schedulers dot, for example, elastic, right? Or I can provide an executor-based thread pool, or bounded elastic, or immediate, which will run the code on the client's thread, basically public static void main, right? So you can do all sorts of things there, but you shouldn't normally need to do that. I consider this a code smell. That tells me that you're leaking somewhere in your code. You've got blocking code in your application, and that's problematic. Right? It's problematic because you want to eventually, if you can, move away from this sort of model, right? If you find that you're doing this, it's very important that you find where this is happening and kind of either isolate it or better yet, remove it. And we've created a tool that you can use called blockhound. Blockhound is a Java agent. It's part of Project Reactor. You can add it to the class path, and if you do anything blocking, like thread.sleep, for example, it'll throw an exception. It'll help you ferret out any of these blocking interactions. Right? So this is very, very nice. We've got this nice API. It's asynchronous and it's potentially unbounded, and we have all these sort of interesting things happening, and yet I didn't have to write a lot of code to get that to work. Think about what's happening there. I have one asynchronous thing, after which I want another asynchronous thing to happen, after which I have another asynchronous thing that I want to happen. Think about how you'd have to implement that absent reactive programming by yourself, by hand, right? In 2019, you'd use something like, threads, and you'd use executors and runnables and phasers and semaphores and countdown latches and cyclic barriers and all this kind of stuff. That's not for me, friends. Remember, there's only one person who truly understands how to do multi-threaded programming in Java, and it's not you. That's the important message here. This is not a message of hope. You're not good enough, nor am I. So don't bother. Use the API, right? Good stuff. So now we've got this code. We've got the scheduler, and the scheduler is what allows us to talk about things like delay elements. So I've got this service, and what I want to do is I want to now create a WebSocket endpoint. I'm going to create a greetings service, WebSocket configuration. Good stuff. WebSocket configuration. We're going to create a bean of type simple URL handler mapping. It's going to create a mapping. It's going to mount the HTTP URL and then do the upgrade to the WebSocket endpoint. So I have to tell the framework, hey, mount the WebSocket endpoint at /greetings, right? So it's going to inject a collaborating object of type WebSocket handler. There we are, WSH. WSH, good. I'm going to make it I'm giving it an order of 10. I don't know if I need to do that. I do need to do that, so there we go. Now there's the simple URL handler mapping. I'm going to create a WebSocket handler adapter. That's just pure infrastructure, so you can ignore that if you like. And then we're going to create a WebSocket handler. And the WebSocket handler is the thing that actually produces the response that we're going to send back to the client. So in order to do this, this is the actual business logic that we're going to create. So I'm going to create a new WebSocket handler here as well. And this WebSocket handler is the actual business logic. That's where we do the interesting work that needs to be done. So let's see, WebSocket handler, there we are. Good stuff. And in order to do that work, I'm going to inject the collaborating object, the greetings service here. I'm going to make this a configuration class. And I'm going to when the application gets a WebSocket client, I'm going to have a WebSocket session established. I'm going to read from the session. Remember, I'm assuming that the session client, the WebSocket client, is going to send me a name. So I'm going to say session.receive, in which case I'll get a publisher of WebSocket messages. I'll read from each one of those. I'll say WebSocket message.get payload as text. I'm going to read from each one of those, and that's the name, right? I'm going to say create a new greetings request, passing in the name. And from each one of those, I'm going to call the greetings service. So I'll say for each new greetings request, call greetings service.greet, passing that in, right? And of course, that can be that. And then from each one of those, I have the greetings response, right? Now I've got the message coming back from the service itself. And then for each one of those, I want to take the string and turn it into a WebSocket text message that I can then send back to the client, right? So I'm actually using that little service that we created earlier to generate an infinite stream of greetings, and I'm turning it, as these greetings arrive every second, I'm turning it into a new WebSocket message, which will be sent back to the client, the WebSocket client. So here's the entire pipeline, if you will. There it is, right? There you go. Just, chat or whatever, okay? I don't like to, again, var for the win, okay? And now I can say session.send chat. Okay, that's the entire interaction. This can, of course, be written as a Lambda. That's very nice. And there you go. That's the entire WebSocket interaction. That's the entire business logic, if you will, of my WebSocket example. But we are faced with a bit of a predicament, a bit of a pickle, my friends. I find myself in a very uncomfortable situation where I need to do something to demonstrate that this works. And if I could find a more reasonable way to do this in polite company, believe you me, I would. But I feel my hands are tied. I haven't been able to yet find a better way to do this. And so I'm going to do something that I'm not proud of, something that I wouldn't otherwise do in polite company, something that if I had any say in the matter, I would definitely not do. I would, I'm gonna write JavaScript. So static ws.html body script window.add event listener load. Ugh. Okay, var ws equals new WebSocket ws. Oh, come on. Localhost 8080/ws greetings. ws.add event listener open. When the socket first connects to the WebSocket service, I get a callback there. And when the new messages arrive, I get an on message callback. And there we are. So now what I want to do is I want to say when the socket connects, I'm going to use the WebSocket that's now ready to use. It's initialized. I'm going to send a message to the service. I'll say, oh, okay. The name is Brisbane, greet Brisbane. And then as each new record comes back, I'm going to log it out. Okay, I'll say log.ev.data. Okay, and there we are. There's the WebSocket endpoint. There's the WebSocket code in JavaScript. Alrighty, is that up? Did it already restart? Okay, let's assume it did. Localhost 8080/ws.html, and there we are. There you go, my friends. It's going to go on and on and on and on, forever and ever and ever and ever, forever, producing new values every second in perpetuity for all time. It has no end. It is endless. It is infinite. It is without fin. It will go on and on and on and on, like the oceans and the skies and the stars and the bugs in your code, just infinite, infinite. So whatever you do, my friends, whatever you do, don't worry. It's fine, because in between the raindrops, that code is not going to keep that thread open. It's going to repurpose that thread and make sure it's available to other things in the system. So while this is not, this is still a resource drain eventually, it's not going to happen anywhere near so soon as it would if you were limited to one client to one thread. This is the benefit of reactive programming. It's not that we've made any one transaction faster. It's that we've managed to make the system do the work in such a way that we can handle a good deal, many more transactions. That's where we gain something here. This is not about making it so that we can handle one transaction faster, it's so that we can handle many more transactions. Now, I've been demonstrating this to you using things that I think are fairly familiar. Things like WebSockets, things like HTTP, things like JDB, things like SQL. All these are fairly straightforward, and the WebSocket thing is pretty interesting. But would I build a high-performance microservices sort of architecture based on HTTP today? Probably not, right? There are better options. certainly for low latency, high performance sort of computing, right, that kind of stuff. And so one option that Google pioneered that was kind of interesting is called gRPC. That's a service framework. It's a way for one service to talk to another. Kind of interesting. It requires that you do code generation, and it requires that every payload be based on Google protocol buffs. So it's very, it's a round hole, square peg kind of thing, right? You've got a problem if you don't want to describe your services in that way. It's not natively reactive either, right? It's asynchronous. You can use a plugin from Salesforce. Do you have Salesforce here? They're a small company in the States. Anybody hear of Salesforce? They use Reactor, right, because they want to scale, but they built a compiler plugin for gRPC that actually emits Reactor-based gRPC services instead of the default one. Kind of interesting. I don't know if I'd use that today, but why not? For my money, though, today, if I had to build a high-performance sort of service architecture today, I'd use something like RSocket. How many of you have heard of RSocket? Not you, Todd. This is one of the creators of it, so I don't want to hear from him at all. None of your sass. So. RSocket is a service technology, so it's a protocol. It's a binary, sort of payload-agnostic protocol for communicating data over the network. It gets rid of a lot of the sort of inherent limitations that you get when you use something like HTTP, right? HTTP2 is pipeline, not multiplexed. A lot of times when you're doing connections from one service to another, you have to connect and then disconnect. This creates a drag. It's very imperformant, whereas with RSocket, you can create a connection and it stays open for the life of your application, so you get rid of that constant ACK and disconnect and all that stuff. It can do all sorts of different message exchange patterns, so request, response. You can do bidirectional communication. There's no such thing as client service in RSocket. It's actually requester, responder. So it's just a really nice protocol, very nice protocol that I think it feels very natural for sort of these kinds of use cases. And as it happens, we actually integrated it into Spring Framework 5.2. So it's actually already here. It originated, correct me if I'm wrong, by folks who were at Netflix and who came then to Facebook. And anything else you want to add to that?
That's pretty much it.
There you go. So people that have been in production, they have stared down the whites of the eyes of production problems, right? So it's a very useful protocol. We have a component model in Spring Framework 5.2, which is already available, which is what I'm using here. I'm going to take my existing greeting service ever so quickly. I'm going to turn it into an RSocket endpoint. I'll say @message mapping. Greetings, okay? And there we go, ta-da! Now, in order to make this an RSocket server, I'm gonna spin up an RSocket server on port 8888. That's good luck in China, so that's kind of nice. We're gonna go ahead and restart the application. And then very quickly, ever so quickly, I'm gonna go back to start.spring.io, the second favorite place on the internet. I'm gonna build a client, reservation-client, okay? And I'm gonna use the right version of Java, and I'm gonna bring in RSocket, and I think the reactive web support, just so I don't have to create something that keeps the port open. And there we go. And we're going to create a simple client that connects to that service and then consumes the never-ending greetings stream of data. Okay, reservation client.zip. Okay, good stuff. Presto changeo. Download reservation client application. And all we're going to do is we're going to start up an application that runs on a separate port, so we don't have a conflict. So who cares about I don't care about the HTTP service. I'm just creating that to keep the thread open. And then I'm going to create a bean that's going to be I'm going to create an application listener, just like I did before. So class RSocket, greetings, client thing, whatever, and I'm going to say, hey, this is a thing that listens for the application ready event, just as before. So when the application is ready to start processing, I'll get a call back here. And when I do that, I am going to take advantage of a RSocket requester. So I'm going to say bean RSocket requester. Okay, and it's going to be an RSocket requester. This is the thing you use to call the RSocket service. So you create a connection here, localhost, port 8888, that's what we said, right? Block, good. And I'm going to inject that collaborating RSocket requester here into the constructor. As before, I'll use Lombok. Oh, I don't have Lombok. Oh, sad, so sad. So we're going to go back here to the build. This is the service. I'm going to find Lombok. There it is. I'm going to copy and paste this back to the other thing. Paste it in here. Good stuff. Look at that, okay? Now, I'm going to make a call to the other service at required args constructor. There we go, good. Now, what I want to do is I want to use that thing to call the other service and get the data that comes over the wire and turn it back into data that I can use. But I don't have any client-side representation of these types on my local machine. So what I need to do is I need to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. Now, I've got my greetings response and my greetings request DTO types here. I'm going to paste them into the client. Here we are. And we're just going to say, hey, new greetings request. And we're going to say, let's say Brisbane, sure. Okay, and as the data comes back, we're going to say greetings. We want each one to be a greetings response, and we're going to then map through it or log, subscribe to each one. And I'm just going to say system out print line. Okay, let's see if that does the trick. Good stuff. Let's start it up. I'll take some coffee. Good stuff. Look at that. So now we've got on the console, our client, our thing, is calling the RSocket service. It's communicating over the wire using CBOR, C-B-O-R, which is the way we're encoding data in this case, but it's payload agnostic, it doesn't matter. And it's getting the data back, and it's natively reactive on the wire. It doesn't actually, this is not problematic. I can keep doing this as long as I want, and it's end-to-end reactive. And there's some really nice properties here. If I make a call to a downstream service and I want to resume later on, I can just stop request. I can just stop subscribing right now. That doesn't mean I've canceled it like it would with HTTP, because you can only get one shot at the apple with HTTP, right? With this, you can just stop for now and then resume a little bit later. I have really interesting, production-oriented characteristics about RSocket. One of them is that there's a payload, there's a message frame in the protocol itself that allows you to say, hey, I'm busy, my service is not healthy right now, you should talk to somebody else. This gives you some very interesting load balancing opportunities, right? So I think there's some very big opportunities here. We've got Spring Cloud Gateway, which integrates this and does all sorts of good stuff as well. We've got security, Spring Security for RSocket as well. All sorts of different opportunities here. I mentioned that this technology had come out of some very, it was the work of some very smart people at very, very interesting companies. There's some other companies. I talked to a lot of different companies all around the planet about Spring and Spring Boot and nowadays Reactive and even more so RSocket. And so in March, there's a small company in China called Alibaba. Anybody here know of Alibaba? They're a small company. I believe they're going to be big. You just mark my words. They've got a future. In March, they invited me, as they do every year, to come hang out with them. And this time I spoke at their Alibaba internal R&D summit, and I gave them the big sort of introduction to RSocket, right? This organization is all Spring. Everything has been Spring for the last 15 years, right? It's all Spring. Increasingly, a lot of it's now Spring Boot and Spring Cloud, and increasingly, a lot of it's now reactive, and now increasingly, it's RSocket. So Pivotal, Netlify, and Alibaba were the first. We founded this organization called the Reactive Foundation, and the first technology there was RSocket, right? Lots of interesting opportunities there. I hope you learned something today. Who had fun? I'm just curious. Who had fun? Who learned something new? Good stuff. I had fun. Obviously, I love this stuff. I'm wearing the Spring t-shirt and the Spring underwear. Obviously, big fan. I love what we're talking about here. I love the opportunities, and I hope you do too as well, my friends. Thank you so much for coming. Have fun. Please vote. Cheers.
Thank Josh. I don't think we've got any time for the
My direct messages are wide open. Just send me a message.
Thanks, Josh.
Thank you.